In an earlier video, I introduced you to the idea of the angular velocity. The angular velocity is the rate at which the angular position changes, and I also showed you this formula that we can use to compute the angular velocity, assuming that the angular velocity is constant. The idea is that we have some object which is moving on a circle, and we say that in a particular process, the elapsed time is delta t, and the change in angle that the object went through is delta theta. If the angular velocity is constant, then the angular velocity would then be equal to change in angle over change in time. So as a quick example to practice using the formula, let's say this is the Earth here, and let's say we have somebody standing somewhere on the Earth. It could be anywhere, but let's just say he's standing on the equator. Now the Earth makes one complete revolution every 24 hours, which means that this guy standing on the equator is going to trace out one circle every 24 hours. So we would like to find the angular velocity of this guy, and we would like to do so in units of radians per second. We're assuming here that the Earth is rotating with a constant angular velocity, and if that's the case, we can just use this formula, omega equals delta theta over delta t. So let's just think about the period of 24 hours where the Earth would go around once, which means this guy makes one circle around the center of the Earth. So for that process, the change in angle would be one revolution, but one revolution is also 2 pi radians. The time interval would be 24 hours. We're almost there. The question asks us to find the angular velocity in units of radians per second. Here we have radians per hour, so let's just use a conversion factor. An hour is equal to 3,600 seconds. So we have hours cancels hours, leaving units of radians per second. And if you put 2 pi divided by 24 divided by 3,600 into your calculator, you'll get 7.27 times 10 to the minus 5. And again, the unit is radians per second. So now we've had some practice with the idea of angular velocity. And in the next video, I will introduce you to another concept in rotational kinematics.